Hello, welcome back. Uh, Need load chat. Okay, now I have the chat. So we can start. I changed the title to live vibe coding because I'm using AI a lot. Um, so let's go back to WebGPU and see how things are. So first thing is that in this code, I just wanted to add some way to send this vertex index to fragment our fragment uh, color function. Okay, to do that, so apparently I can just define a struct here. Uh, okay, struct vertex. Mm, what kind of vertex? Yeah, vertex. And then we will have built-in built-in position, built-in position, position pose, and it is of type vec4 f32. And then here I want to add at site location 0 color. Okay, no, this is not the color, this is just some index, vertex index. Okay, and then here this is a vertex, right? No, okay, I see. This is the vertex index, and this is vertex index. And what it returns is a vertex. It is not returning this, it is just returning a vertex now. Vertex info. Now that I have that, I can use it in here. There is the output. So we do var vertex info of type vertex info, and then this vertex info has a position, which we'll call it, vertex info dot position is that, and vertex index is just the vertex index that we have here. Oh no, this is just I just want it to be F32. Vertex index. And now we can, we're sending vertex info. The thing is that this is U32. We have to change, cast this to F32. Okay, I'm gonna comment this one, and I will. Okay, I'm comment this one. Now we say that this function zero, it will return, it will get some F32. Occasion 0. Location 0. Vertex index. This is F32. And then right. And then we define the color by this thing, and then we multiply it by here. Should be okay. No. 0.2. This should be 0.3 as well. Does this run? Okay, there's some error. Expected found semicolon. Okay, these are supposed to be comma, I guess. Can you just run the code, by the way? Exec out, then okay. It says expected this, found this, and two. Okay, no, we have to do recompile the code. Okay. Undeclared, identify a vertex index. It's vertex index. Symbol, vertex symbol. There's the position. Okay. Okay. There's some error somewhere. Get fragment color entry point not found. Oh yeah, okay. This is fragment. Okay. So it works, but I don't understand why. I mean, I get it. So we have vertex index. This is the variable, and vertex index is the built-in vertex index. Like it gets the value there. But this is the variable name. So if I want to use the different name for this thing, yeah, I would call it index. So I'm not sure if I understand this correctly, but so for example here, if I'm defining built-in position, it means that position of this vertex should be connected to, like this variable should be connected to the position of the pixel that we're working with, I guess. And then this vertex index should be connected to this location 0. And what is location 0? The thing is though, so if I run this, so the 0th index, index 0 is the top one, it's this one. And there I put 0 in the green, half in no, sorry, what's the colors in order? The first one is red, second one is green, the third one is blue, RGB. Okay, so I do have so the top one is with r equal to 0, okay. We write it here. So in32 RGBA, okay. Well, R is red, G is green, B is blue, okay. Okay, can I do this, for example, 0? Just want to see more clearly if this alpha thing also works. And this alpha is when it's 0, it shouldn't draw right. It should be But why is it not? Alpha is not working, I mean? So the top one is this color. Top part is the red color, which is 0.2. And then there is 0.3, 0.2, and the last one is 0.60, 0.2. And alpha doesn't work for some reason. Okay. There is the blend. Okay. Now, if I want to change something in shape, for example, okay, this alpha didn't work. How do I make this alpha work? So apparently I have to change the blend state. Here, blend. Okay, we have to works. Okay. What do these things mean? So I have to add, yeah, something like this. So color 1 minus source alpha at 1 minus source alpha at GPU, how to mix, we basically set how GPU should mix the new pixel with the old pixel already on your screen. Source says the output from your fragment shader. Destination, the pixel currently on your screen, the blue background. Operation, how to combine them, usually add. So here we just say handles red, green, blue. So when we say 1 minus source alpha, final color is the new color times new alpha. Live vibe coding, yeah. I don't know. I didn't know what to write. Hi, how are you doing? Welcome back. Yeah, I guess I have to mention somehow, somewhere in the description or the title that I'm using AI and I'm not fooling everybody. That's the reason I have to write it to live wipe coding. What wipe stands for? No. I think wipe coding means for using AI, no? Very inefficient but entertaining. Oh, okay. I have to then change it and put all the wipe as like all of the characters should be capital, right? like V capital I capital B capital E capital. Yeah, okay. I will change it at the end of the stream. I'm doing good. Yeah, how are you doing? How is the progress? So I just started Mach Engine, basically the library in Zig with the GPU, and I'm trying to learn the WebGPU stuff like the shader here. I'm trying to learn it, shader language and stuff. Yeah, it's been a while. So I finished chess because it was fun, the chess program that I did. But yeah, I want to go back to what I like to do right now. So it was a small project. I finished it now. I'm back in here. So do you remember there was this discussion on Bitboard in the Discord that we had, that for chess engines they use a Bitboard, uh, like for every piece. For example, for Rook, um, not every piece, but I think it's for example, for white rooks, they use a bitboard where you basically put zero on the squares where the rook is not, and for the place where the rook stands, you put one. And then chess engines use that with a little bit of crazy stuff. So I was thinking, could we use that for sand? So, for example, if we want to simulate sand in the screen, do we have to define um, because sand is basically, we would have to work with every pixel in the screen, right? What is Zig? Never heard of it. Zig is like programming language, like low level programming language like C. It's a pretty new, yeah. And we agree that Beatport is a great thing. That might be chess version 2. Yeah, exactly. Yeah, maybe in future I want to do, yeah, if I want to do more algorithmic chess engine type approach, I will try to do Bitboard. Yeah, I put it there in the goals and in the discussion in the Discord channel, in Discord server, as one of the things that I might do later. Yeah, but I was thinking maybe we can use the idea that has been used there, for because so for example we are trying to draw stuff um, in the screen, but we want to also have calculation for example, collision and ray tracing and stuff. Some of the stuff is not just in the shader language, it's also in CPU. Then it's gonna be really expensive if we want to track all the sand points, like all the pixels. I don't know if it's a viable approach, or is it even interesting, or could it work in any sense, or it's just a crazy idea. But I had this idea. I wanted to, I don't know, maybe with this maybe I can try to make it like try to see how it goes, but I don't know. um, so here we have a source. Source is the one that we, so here when we define a color for each pixel, basically we have a source and destination. Destination is um, uh, like the, I mean, Destination is where the color will go, and source is basically the output of this thing, this function here. I mean here, get fragment color, the output of this. And then here, okay, and I'm saying to add them together. Yes, right. Um, Destination, Discord, more people, more ideas. Oh yeah, okay, thank you. Yeah, what do you do professionally? What's your age? I'm around. I actually don't know what exactly my age is, but it might be around 33, I guess. But yeah, I don't do anything right now. I'm just doing streaming for now. And I'm trying to learn how to design games, like mostly two-dimensional graphics, and I mean not graphics but games. Something between 18 and 40. Yeah. Okay. That would work, yeah. Okay. But so it's a really strange thing. So where I come from is the I come from Iran. So in Iran there is this weird sense that if your birthday is today, if you had your birthday yesterday, so no, it's not. How can I explain this? It's a weird thing where your age is the year you're living inside it. So it's like, I don't know how to say. So the baby who is born 6 months is a 1 year old baby. I mean, it's a my mother kind of sense of like it's his first year of life, so he's 1 year old. Yeah, I'm from Iran, and then there is um and then there is a European standard where, for example, if I say, for example, if I was like the baby was born 2 years ago, he's like 2 years and 3 months. He's 2 year old. He has to say 2 year old. But if I'm like yes, if I'm using my mother's standard, I have to say 3 year old. But if I'm using the European standard, I have to say 2 year old. So it's always confusing. Assalamu alaikum. So assalamu alaikum is like I think it's Arabic. So in Iran, there is a small portion of the south and southwest of population that speak Arabic, but the major central part they speak Farsi, and I'm from northwest where we speak both Azeri, Turkish, and Farsi. So we say so it's just we just say salam, so or durut, and then yeah, and yeah, that one is a Turkish way of saying salam alaikum, assalamu alaikum, I think. I mean, I've never been in Turkey, and I've never uh, been taught to how to write in Azeri. We're not allowed to, like in Iran they don't teach it in school. Anyway, By the way, I didn't ask you where you're from. Like, how do you say hello in your language? Programmer, but I just want to call. Oh yeah, okay. Yeah, I guess I have to say that the same here. Okay. That I also want to code. I just like to do this. We say namaste. Oh, you're from Nepal. Okay, yeah. Namaste is okay. So, how do you call the? So, what's the language that you use in Nepal? Um, I'm assuming there should be one major like from which language is it? Namaste. If you're good to me, I'm good to you. Oh yeah, okay. I mean that's um, I'm sorry, bro. From you didn't offend anybody, honestly. I'm just you know, I was just maybe I was going too far. I was just trying to explain. That's like yeah, that's not generally like for example in future if there is an opportunity if you go there. I don't know if you see somebody who's from Iran if you like yeah, but it's not like a big thing. You can just say the same thing, and it's still is okay. There is no offense, absolutely zero. It's cool. We say, oh, how do you pronounce that? Okay, I have to put this in Google. Okay, Nepali, hard guess. Yeah, okay, but it depends on the language and so there are some country. So in English, some of the countries and the languages, the names are the same. So, but some of the like some countries have multiple languages, and so for example, for China, yeah, we used to like we are used to saying that there's a Chinese language, I guess, but the name of the language is Mandarin. Like it's that's why I'm asking. Like in some countries, the languages have different names. It's not just from the, you know. Um, I thought that you're French. No, I am. I mean, I live in French. I have. I'm learning French and stuff. I live in France, and yeah. Um, my girlfriend is French, and yeah, my future is here in here. But my original, yeah, nationality is Iran. So what was the okay? I wanted to see the pronunciation of okay. J- uh, Dzień dobry. No, Dzień dobry. Okay. Oh, very good. Okay, thanks. Makes the Nepal appear more inclined to west. Oh yeah, okay. Why? I think it's I think it's um yeah, I am not really, I don't exactly understand the which country is more inclined to west and which country, like I know that Iran is a very, I cannot even speak about it because there is so much, I don't know how to say, it's like it's so complicated to talk about it, but and I don't understand some of the stuff, but and I don't even have the slightest information about many other countries, yeah, but it's good to know. But I know, like I was in Vietnam, Hanoi for 1 year, and Hanoi was I wouldn't say inclined to they were not inclined to anywhere generally, I think. Maybe they like the relation with the US, but they also like the relation with China. It's like I don't know how to say it. That's what I saw. I don't know. Yeah. Thank you for teaching me um saying hello to you. Okay, namaste. I will remember, but Jien dobre. Jien dobre. Jien dobre. No. Yeah, I cannot completely get the last part of the pronunciation of the first word. It's more like good morning. Oh, okay, I see. I see. Okay, thank you. You're quite a travel? No, I mean, I just visited Hanoi for 1 year. I was there. I was a student there. Or Siema. Okay. Which would be, what's up? Okay. Siema. Okay. Okay. I will try to remember. This one is a little bit difficult to remember. Jien Dubre. Okay. Very cool. Okay. So here there is vector, destination vector, source vector, destination vector, operation add. I want here source alpha. So for color, I get source alpha add, and then here I do have to do operation add, source factors 1, destination factor 0, factor 0. Okay, so this means that the source is what I am defining to be, and then destination factor is a source alpha. Well, it depends on the source alpha, I guess. And then we do add. Here alpha is 1 for the source factor, 0 for destination factor, operation add. Okay, let me see if there is an error first. To be honest, it has very interesting syntax. Yeah, I mean, I like it, so I hope you like it too. Yeah. Show us the front end. What do you mean front end? You mean the result of the code? This one? So I'm trying to make one of these vertices like a little bit transparent, and it doesn't work. Like it should be even much more transparent. Like one of them should be completely transparent, and it doesn't work for some reason. I'm trying to understand why. VLang. Oh yeah. Okay. VLang was also interesting. V programming language. But VLang is a little bit easier to write to me than Zig. Zig is a little bit more explicit and verbose. Like, I don't know how to say. VLang is even more recent than Zig, by the way. Almost, I guess. So it has very similar syntax to Python. Yeah, okay. Yeah, it should be newer, but I don't know how does it work. Like, is it like specific for okay, simple language for building maintainable programs? I don't exactly know what they're aiming the language for. Is it gonna be like Zig, general purpose language, or is it going to be like Odin is also general purpose language, I guess, in some sense, but it's more for game design. Be right back. Okay. Simple language for building maintainable programs. Okay. Applications. Okay. Let me continue. So GPU operation is generally to replace shader return alpha 0.1. New color times new alpha plus older color times 1 minus new alpha. Multiply the new color by its visibility. Okay, then I put color operation add source factor source alpha. Okay, destination factor 1 minus source alpha. So here 1 minus, yeah, this is 1, that's why it doesn't work. It should be okay. So I'm saying source alpha. No, I think I should write it opposite. No, source factor should be source alpha. Destination should be 1 minus source alpha. Okay, it doesn't. I wrote this. This is Earth. Yeah. Okay, so okay, blending. So the equation is final color destination factor. Destination color is the color is the new color we pass in, and sorry, SRC factor is the new color we pass in, and then DST factor, okay, already in the buffer. Okay, we do the operation and we add them together. And then there is the alpha. Alpha says source factor should be 1, destination factor 0. This is the equation. This is the final alpha is final alpha, new alpha times source factor, old alpha times destination factor. Color, this should be final alpha. Okay. So here I put the source 1, source alpha plus destination alpha 0, destination factor So I'm just saying that, so for example, I'm just putting the new alpha to be 1 always, but I'm doing, okay, I don't understand what's the use case of this alpha then? Like, can I not just comment this and this will do it? The color thing should work, no? Itself by itself. Let me see if there's error here first. Okay, yeah, this is cool. Now there is the opacity, lower opacity on the first vertex, and then the second vertex has a bit less opacity, and then the last one has has the least opacity. It's a math equation. Okay, so now I want to ask, okay, what is this final alpha for? Hey, young hunter, welcome back. Have you thought of doing AOC? What is AOC, by the way? AOC, AOC. Yeah, I don't understand what is AOC. Um, Sorry, you would have to explain to me. Daily problems. Ah, you mean I tried to do a program. The thing is that I mean I like to do it, but then the problem is, so for example, yeah, I'm assuming that they write the program in C, and then like there is a lot of details here for Mach. I mean, it's a cool thing, it's a cool idea. Yeah, but I'm not really. I'm more a person who wants to, like, I have to set the goal for my work myself. Otherwise, I'm not gonna be able to do it. And like, if I see problems, if I'm not understand, like, I will check them though. Like, let's see if there is. Okay, is there daily problems for WGSL or WebGPU learning? Is there a website for these things, or we have to just search it in Google? Okay. AUC. It's an API that lets you do two basic things. Learning website. Start learning. Okay. GPU high performance graphics rendering, direct access to GPU hardware stuff. Simple web GPU application. But these are all the thing is that I mean it's generally the same, but they're browser oriented. Like I don't want to do it in browser. Okay, let's go a little bit further. Let me show you what I'm saying, by the way. I always forget this if you don't tell me. Fundamental whatever. Okay. Okay, so yeah, these are this is one of the websites that I found. The fundamentals. If you already know JavaScript before you did read this article, I mean, I I don't remember much of the JavaScript, so like it would be better if it's C, because if it's C, I can easier. It would be easier for me to. I still C will be difficult for me. There is a vertex shader. Okay, fragment shader. There is the buffer, viewport, scissor, vertex buffer, 0 point. Okay, bind groups, view, diagram of a GPU setup to draw triangles by using vertex shader and fragment shader. That is about this diagram. There is a pipeline. It contains the vertex shader and fragment shader the GPU will run. You could also have a pipeline with a compute shader. Okay, I don't know what's the difference between compute shader and fragment shader, but I think fragment shader is when we want to specify each pixel directly, I guess, but compute shader, I don't know. Simply one GPU, web GPU tutorials, yeah, generally for now. Because it's I'm just learning web GPU in general. And then I want to use it for like to do a simple stuff in Mach. So I'm using Mach Engine. I don't know. I mean, they have some examples. I can try to read and understand their examples. Mach Engine example. Okay, here there is the Mach Engine and examples. And this is the triangle example that I'm trying to change it with the help of AI. Which is, I mean, it's still slow, but like I consider what changes I want to make. Like, for example, if I want to draw a line, how do I do it? If I want to draw the other shapes like rectangle and stuff, and then I want to go further than that. Like, how can I? Um, yeah, it's. I will try to do that. That's like. I mean, if there is a thing that helps with that, it's cool. It's really good. But then most of these pages are generally like there's a lot of explanation, and then I'm gonna get lost after some point. Like yeah, and the languages are not really so it's like JavaScript and stuff. I mean, I don't know. Maybe it helps in the long run. Like these are JavaScript, I think, right? Like all of this console that load and stuff like this. Yeah, exactly. It's JavaScript, and then you do use HTML and like a canvas, and then you try to see the result. I'm not saying it's bad, it's just that it will make it more difficult for me to follow. And then this, um, what is this website? Daily Dev. Best practices and tips, various aspects of WebGPU API, including loading texture, buffer uploads, bind groups, dynamic shader. Um, oh, I think I have to go inside the thing, become a member. Yeah, they are more web-oriented examples also. So, I mean, I understand WebGPU started for um, more for like web-oriented projects, but then right now we can also use it to make games and stuff, right? I mean, as far as I understand. We go back to this code. But yeah, I will check them out of stream. Yeah, yeah. It's I think it was initially like specifically was designed for more web use cases, but then like over time, because of some of the stuff, some of the aspects that it had, it gained popularity for some other project as well. For desktop project like PC and stuff, you can still do things there. It's okay. Um, I'm just checking what I'm saying is right or not, because if I'm going in the wrong path, then I have to change my direction as soon as possible. I mean, that was my understanding. I don't know if I'm just asking a question from AI. So yeah, it says that WebGPU for native desktop application and executables, not necessarily websites, is currently one of the hottest trends in system programming, especially in Rust and Zig communities. Mm, yeah, I think the general idea behind it is that because WebGPU is like a cross-platform thing, so it's easier to use it for um, like for your project. So they're like in and the Zig and Rust are also kind of cross-platform. Yeah, Zig is cross-platform. The Rust is, I think, also cross-platform. So it's like, it's an interesting thing. Yeah, and when used on desktop, it is often referred to as native web GPU. And but it's more like so it's like a new thing. It's not being adopted by like the big companies and stuff. It's more for like new game engines that come along, the smaller ones, like the Mach or Bevy engine in Rust. Um, like they in their ecosystem they use WebGPU more often, like the native WebGPU exclusively. So you can make games with them for systems and stuff. I mean, that's what I'm seeing. I don't know how far of this the details. Okay. So going back to so I now know more or less we can just change the color and alpha. Okay, I was trying to understand what's this alpha doing here. Like because this color thing is just doing everything we want, no? Move it because GPU treat color and alpha as two separate calculations that happen in parallel. Okay, so we cannot remove alpha part. We have to put it there. Uses the alpha value as a tool and multiplier to mix the color, but it does not save the alpha value itself. Here is the difference. Color calculates what you see. Alpha calculates what is saved. This equation answers how much red, green, blue should be in the pixel. So that's color. Set to mix the ratio, but the result is produced is the result it produces is just RGB. But then alpha part is okay, how opaque this pixel is now. Like the calculation of opacity already mixed the color, the dirty window example. Game UI background, you have a semi-transparent gray menu background, alpha 0.5. Foreground, you draw a solid red button on top of it, alpha 1. Mix, so the color mix gray and red result red. Alpha Math needs to figure out the new opacity. If you ignore this or do it wrong, the GPU might write alpha equal to 0.5 back to the buffer. The compositor draws this whole UI onto the game world. The button will look like a ghostly transparent. Okay. I mean, I don't understand it now, but I guess I will understand these things later. But more or less, this is the format of doing things. Like, now I want to do. Okay, can I send or no? Okay, so for raycasting, for example, what did I do for raycasting? So I used to do the calculation in some of the calculation in CPU for. So I had some a bunch of platforms, and then there was the user, and then yeah, we can actually try to do that. Okay, so for example, I have a user and I want to draw the user in the thing. Now I want to draw it as filled circle with some radius, like small radius. How can I do that? So for example, it could be in the center first, and then we can try to change the position later. So first I can try to define it here somewhere. Const public const layer struct, and then I will put big const vector 2 is just vector. Yeah, okay. Now my player has a position vector 2. Okay. Now welcome back. So I will put the player as a struct. It has a position, and now I want to send this position to the shader. And in the shader, I'm gonna try to draw some radius. I can also try to send the radius of this thing. No, or okay, I want to use this WebGPU thing to draw this player. How do I do this? So I can try a circle. I will put the radius here. F32. And then here, okay, where should I even define it in this place? Like, because it's not a module. Okay, it's not a system also layer. It's more like an object, no? Let me ask this again. Oh, okay, first let me ask. I can also check on the examples in Mach. Find, let me check first Mach Engine. On GitHub. Samples. Okay, so here, transparent window, custom entry points. I guess it would be custom entry point, no? So, yeah, we don't care about that. Color target. To frag main. Vertex main. Okay, there's tick. There's background, render pass. Line, there's the draw. And color finish, release, submit. Is it this? It's not the. It's the same code as the other one. What is this? This is weird. No. They have a piano. Is it texture or is it just drawing? Core. Uh, hardware check. I want that. Text. Player position to dig. GPU every frame. Uniform buffer. Okay, we have to use a uniform buffer to send data from ZIG to GPU every frame. Why do you store file in extensions like .app.main.init aren't file extensions? Am I missing something? I have absolutely no idea how things are done in Mach, but this is how they do it. So I cannot really answer this question. But like if you want to check their thing, there is the website. Let me see if there are documents, by the way, here. Some documents on modules, how to define modules and stuff. Let me bring up this thing. It is memory stored. No, these are like this is the ecosystem of the Mach engine. Like there is overview system of overview of the system. So there are a few different concepts which can be used together to compose Mach object system. There is a modules collection of global states, system, and objects. System is like a function or a list of system functions that could be run. Objects like a slice of struct, but with various features and performance benefits. And there's of course relations. Optionally attach objects as parent-child of the other objects. No, not physical file storing. It's not a file extension. Yeah, it's just how we introduce them in Mach. This is a convention. Okay, we go back to the code again. So scale aspect ratio correction is an oval. Group binding 0 match RZ code layout. Uniform player. Player. Okay. So we define a uniform variable player. We define the struct for it first. We can actually do that in here in the shader here. Struct layer, and then I will just put position like 2 F32, and then there is R F32. Oh, I see so many mistakes. Sorry. Well, it's okay. I mean, I don't even know what I'm talking about. So, so there's the position vector 2. There's the radius F32. Um, that's my player, right? Or should I? No, it's okay. And then I use this definition for player, where so I do group 0. Okay, and then binding 0 var uniform player. Okay, that's it. Okay, so now I have to understand. So uniform, I get it. I guess I've seen it more. So I've seen this in OpenGL as well. I mean in GLSL. I understand what this is. This is the, so we put the variables uniform. These are the variables that allow GPU to access a CPU thing just to get the data or the variable value. Like, I mean, that's roughly what's happening, I guess. How far that's as far as I can. I mean, I understand. And then binding and group, I am not sure what they are. I'm gonna have to ask. So, what is group 0 and binding 0? Okay, so group X and binding Y access two-part coordinate system, like mailing address to locate resources, buffer textures, samplers that you send from your CPU code to your GPU. Okay, so whenever we are sending data from CPU to GPU, we need to use group and binding. Think of it as hierarchically. Okay, a group is a set or building number. Binding is a slot or apartment number inside the building. Okay. Oh, okay. So it's like a way to identify which kind of so it's like labeling the data that I'm sending from CPU to GPU. And in GPU, I have to also use this label to access this data. That's what I understand. Okay. Optimize performance based on frequency of changes. Finding a resource takes CPU time. So you want to bundle things together intelligently. Group 0 are the globals, things that stay the same for the whole frame. Camera views, sun direction, whatever. You bind this once at the start. Group 1 material, things that change per material. Like wood texture, shininess. You bind this when you switch from drawing trees to drawing rocks. Things that change per object, position matrix, color tint. You bind this before every single draw call. I see. So it's like, um, yeah, okay. So for group 0, we try to use them for the things that are the same, the whole, all the frame, like in one frame. But like in each frame, they could change. Like they have the highest priorities, I guess, in some sense. Things that change per material. Okay, they don't change as much, I guess. Things that but is this an example or is it like a requirement? I think this is just an example. By splitting them, you don't have to re-upload the heavy camera data just because you want to change the texture. I think this is just a example. Yeah. It's basically we have to group things that based on how frequent they change in different groups so that GPU could um, like access those data efficiently. That's what I'm getting. I'm not sure how far this is true. How it connects zig to shader. Okay. So we have to define group 0 and binding 0 somewhere in the zig code as well. That's is that true? Yeah, we have to define entry there somehow. A buffer at binding 0. Create the group. Okay. So in the pipeline, we have to bind the group layer, entry buffer, vertex true, fragment true, uniform fall. Okay. Create, bind group layouts. Okay. With some descriptor. Please create the actual bind group. Bind group, Windows device, create bind group, GPU, bind group, descriptor. Okay, I wish I could see an example because the thing with the AI is that sometimes they have a version problem and they don't really produce the same code. We have a tag name, pipeline, okay, and there's the tick. Mm. Um, okay. So there is more work to be done. I have to learn how to send the coordinate for the player and player radius, like these two variables from CPU to GPU, for it to draw the player. And I will do that uh, probably tomorrow morning. Hopefully tomorrow morning I will be here, and then I mean morning Paris time, and then afternoon also, like 1 or 2 hours each session. And I will just I will also try to read more at night, of course, offline, to understand things better, and, yeah, and to proceed faster. Thank you all for watching. Don't forget to like the video and follow the channel if you haven't done it already. It would support us a lot. And yeah, thank you for watching. Have a really good day or night wherever you are. Take care. See you. Bye bye.